Hello everyone and welcome to today's video. It's been a while we touched on packet engineering and today we are looking at OSPF. So this is part one of my OSPF series. So we are going to design an OSPF packet from the initial stages of the OSPF neighbor states. So on Cisco's website, we can see the neighborship states. From down, it goes to attempt, the init, the two-way, and to the Exstart, where we have the designated router and the backup designated router. So in this video, it's only part one. The script is going to form a neighbor adjacency up to Exstart, where we have DR and then BDR on multi-access segment. So without wasting much time, let me show you the lab. So this is the lab. I have a simple Wireshark capture over here. So basically, I have two routers. This is router one, and then this is R4. So they have neighborship adjacency over the multi-access segment. So show IP OSPF neighbor. So as you can see, this is the designated router. So R1 is the designated router. Then R4 show IP interface brief. Sorry, so IP OSPF neighbor. As you can see, R4 is the backup designated router. Okay, so this is the Wireshark capture that I have over here. So I have the OSPF packet expanded. So as you can see the attributes of the OSPF packet over here. So back on Kali, I have my Kali machine connected to this multi-access segment. So as you can see from here, there is no any other adjacency with the exception of the R1 and R4 talking to each other or having a neighborship adjacency with each other. Okay, so back on Kali, I have this simple script over here. Just trying to zoom it. Okay, so within this script, what I'm going to do is that I've defined the script to be a Python script. I have I'm loading or importing everything from Scapy. I'm loading the OSPF model, and then here we capture a packet from the segment or the network. So because we are on a multi-access segment, so we capture or we sniff one packet, which is destinated to the well-known OSPF IP address, which uses multicast. And then once we capture the packet, what you can do is that you can use this is called um, indexing. So in Python or in other programming, we have indexing. So once we capture the packet, we have a lot of fields over in that packet, as we saw over here, and then we change the values of that particular packet. So the first of all, what we're going to change is to change the source MAC address for the packet that we captured on the network. The next thing that we can do is to change the IP address to our IP address. And then the next thing we can do is to change the router ID to 555 quadruple 5. And then we disable the checksum of the OSPF packet. And also we'll disable the length check on the OSPF packet. And at layer 3, we also disable the checksum. And then what we can do here is that we'll just loop it. So for IP in that particular range, that's from 1 to 50, we are going to send this number of hello packets, which is going to form a neighbor adjacency to the Exstart, where we have the DR and the BDR um, forming adjacency. So without wasting much time, I'll just run my script, Python, fake OSPF neighbor. So let me bring it here. And I'll run the script. So before that, there is no other adjacency over here. Same applies to this one. So now back on Kali, you see the packets has been sent. Now let's go to our routers over here and run the command again. Show IP OSPF neighbor. So as you can see, we have a neighbor adjacency with 555, and we are in the Exstart state, and it's a DR order. That means it wasn't elected. So same on R1. So as you can see, here too is init DB order. As you can see, the session time has expired because we are not hearing from that particular neighbor again. So the dead time expired, and therefore the adjacency has turned down. So this is part one of designing the OSPF packet. I'm still in the process of designing the advanced packet, so I can show you from here. I'm still working on it. And when I'm done, I'll continue with the part two of the OSPF packet. Thank you for watching this video, and see you in my next video.